All right, so today we're going to look at another confidence interval, but here we're going to be looking at confidence intervals for population proportions. So recall from section 4.2, the probability of success in a single trial of a binomial experiment is P. This probability is a population proportion. Now we'll learn how to estimate a population parameter P using a confidence interval. So as with confidence intervals with population mean, mu, we will start with a point estimate. So the point estimate for P, the population proportion of successes, is given by the proportion of successes in a sample. It is denoted by, we're going to use P with a little caret above it, which is called P hat. And we find that by doing X divided by N, where X is the number of successes in the sample and N is the number in the sample. So very similar to what we saw when we were finding binomial probability. The point estimate for the proportion of failures is going to be considered Q hat, which is going to be 1 minus P hat. And the symbols P hat and Q hat are read P hat and Q hat. So looking at this first example, in a survey of 2,939 United States adults, 752 say that they recycle. Find the point estimate for P. So P hat, remember, equals X divided by N. So here we have a survey of 2,939 adults. That's going to be our sample size. And the number that say yes is the 752. So 752, divided by 2,939 is going to give us our P hat. And we're going to round to 2 decimal places. It'll depend on the problem. So here, let's do 0.26. Okay, a confidence interval for the population proportion P is still P hat minus our margin of error E, which is less than P, which is less than P hat plus the margin of error E, where the margin of error E equals our normal distribution critical value, ZC, times the square root of P hat times Q hat divided by N. Okay, and the probability that the confidence interval contains P is C. All right, so recall a binomial distribution can be approximated using the normal distribution if N times P is greater than or equal to 5, and N times Q is greater than or equal to 5. So when N times P hat is greater than or equal to 5, and N times Q hat is greater than or equal to 5, the sampling distribution for P hat is approximately normal, with a mean of mu of P hat is going to equal P, the probability of success, and our standard error, so sigma of X bar, is going to equal the square root of PQ divided by N. Okay. All right, so we have some steps again to constructing our confidence interval. These are going to be very similar to the ones we've seen before. So the first one we're going to do is we're going to identify the sample statistics. N and X. So that's what we saw in that first example. Second thing we want to always find is our point estimate. Which is going to be that P hat, which is X divided by N. And then we want to verify that the sampling distribution for p hat is approximately normal. By checking that n times p hat is greater than or equal to 5, and n times q hat is greater than or equal to 5. Okay. Our fourth step is that we want to, once we've checked that, we can assume it's normal. So then we can find our critical value. Z sub C in table 4. And remember, normally that we're going to use 90, 95, or 99%. So that comes in that box at the bottom. Then we want to find the margin of error. Which gives us E equals our critical value times the square root of P hat times Q hat divided by N. And then lastly, construct your confidence interval. Okay, so with this, make sure that when you are doing your inequality notation, make sure that in the center, you're using P and not mu, okay? That's gonna be a common mistake that's made. So that's why a lot of times you're going to see that confidence interval written as an interval notation, because then you're not gonna be making that mistake of this center notation, okay? So be careful with that. All right, so earlier I said round off rule is going to usually be 2, but with one thing we have to remember, and actually this is what you're going to see in your homework, is that proportion is representing probability. Remember, we represent probability with 3 decimal places in your